All right, so we're on the factoring, and it says, this is going to be really the first introduction to factoring. And so my claim over here that what you're going to be doing is one thing is going to be factoring. So what's factoring? It's writing things as products. Now you need experience in multiplication and division to be able to do this. If you don't have that experience, it's going to be really tough to do factoring. So we're going to take this problem over here, which is an addition problem, and we're going to be writing it down as a product problem. And it's going to take some effort. But again, your past is necessary for you to understand what we're doing over here. We certainly have a method for you, and we will go to the whiteboard and discuss that method with you, right? As we go through this method over here, then we go to examples. But first, it's going to be a short lecture, and we'll talk through it, okay? So let's take a look, and I'm going to do another share with you. And I got to do one thing. I got to start the share for you. Give me 1 second. And I'm a little unprepared at this point. I forgot to prepare my whiteboard. I'm going to do that now. And what page are we on here? 86, right? Just give me a second. I know it seems like an eternity sometimes. And I'm going to do a share. And again, I know this first last sentence is, when does it end? It ends when you understand something, and then you want to move forward. All right. So this is polynomial factoring, and we certainly have a method we'd like you to follow, a procedure. And procedures are nice to have when you're introduced to a topic. I grant someone can say, well, I want to do something different. We're not going to stop you. But I'll be honest with you, I've observed a lot of students doing things differently, and really their life becomes a nightmare. So someone's going to say, well, what do you mean by polynomial factor? You're going to be given a polynomial like this. And then someone's going to say, you need to rewrite this as a product. All right. That can be really difficult for some students. They look at it and say, that's not possible. My goal over here is to tell you, if we're asking you to rewrite something as a product, it's possible, and it's likely you'll be able to do it if you try. So the claim over here is that this polynomial here can be written down as two factors. And those two factors would be x plus 3x minus 1. Now, what's nice about this is we can check it, see if it's true. And how do you check it? Well, this is where your experience in multiplication comes in. And we're hoping that your experience in multiplication, you've practiced it enough, you start to realize that multiplication, generally speaking, should be quite simple, especially for polynomials. And what are you going to do? I'm going to check it. And what would you get here? X times x is x squared. Then you get minus x plus 3x minus 3. What does this give me? X squared plus 2x minus 3. Exactly what we expect. All right. My claim over here is, from your past, you should be able to understand, if this is to work, it's got to be of this form over here. Now, what am I saying over here? From my past, I realized that this term here, which is x squared, had to come from this thing. And this term over here, which is 3, had to come from these two over here. Now, the problem is this over here, and I want to point out the problem for most students. It's this business. And this one I'm going to claim trial and error is what's going to allow you to learn how simple this is going to be. Now, someone says, what do you mean trial and error? You have to try something. So for example, if I put down, I'm just going to arbitrarily say, if I put plus here and minus here, and I tried it, let's try that. What do you get? X squared minus 3x plus x minus 3. What I'm going to claim over here is I definitely get the first and the last. Do I get the middle? No. So this try didn't work. So you need to come up with another try. So someone said, if this didn't work, what's another good try? I'm going to cross this one out. Well, I'm going to say, you got to try something different. but there's very little choice over here. So what would the other choice be? X minus 1, X plus 3. Does that work? Well, we just showed it works. Here's the deal about these. Factorizations are going to be unique. There's going to be no other choice. They're unique. That's the only one that works for that. All right. So we need a general procedure to proceed forward on. A general procedure. General. This is going to work in this section of the notes, and it's going to travel nicely if you take it along with you. All right, it's not bulky. Let's take a look what they say to do. Number one step, you need to look at your polynomials that they give you to factor. You need to look at these things. How many terms are there? There's 2 terms there. What you're doing is this. You're asking yourself, do those two terms have any factors in common? And if they do, you're going to pull it out initially. Well, between 3 and 6, I hope you realize 3 would be the greatest common factor. Between x and x squared, x would be the greatest common factor. Then what's left over? This over here. I got to tell you, though, you still should check this. And what do you get? What's 3x times x? 3x squared. And what's 3x times minus 2? Minus 6x. Is this identical to this? Yes, it's the correct first step. All right, correct first step. All right, step number 2. And again, we write problems that will reflect this. Sorry about that. When you have 4 terms with no GCF, let me look at an example over here. There's 4 terms here. I'm going to point them out to you. X squared minus 3x plus 4ax minus 12a. These 4 terms have no common factor other than 1. So we're going to say no GCF. No GCF between those 4 terms. What they say to do, right? Now, granted, this is kind of nasty. We could write them so it really doesn't work out nicely, but for the most part, they work out pretty nicely. We're going to divide the problem. We're going to divide the problem into 2 groups. I'm going to point out what the 2 groups I'm going to put into. First 2, second 2. These are the 2 groups. We're going to divide into 2 groups. By the way, does that always work? No. The other thing I want to recommend to you is that the middle sign, for the most part, should be maintained. Does it always work? No. Initially, that works like a charm. All right. So first group, second group. And we'll do other examples, by the way. All right, so we did that. Divide into 2 groups. Then what are you going to do? Look at those groups and see if they have anything in common. So let's just do the first group. X squared minus 3x. Do they have a GCF? They do. And what is it? X. So the first group factors to x times x minus 3. You can check that because x times x is x squared, and x times minus 3 is minus 3x. Does the next group have a common factor? It's 4a. Okay, 4a times what? 4a times x would give you 4x. 4a times what would give you minus 12a? That would have to be minus 3. Right. What are you doing now? You're looking at these 2 groups, and you're seeing they have something in common. They have a GCF in common. And what is a GCF? X minus 3. What are you left off with? X plus 4a. All right, can this be checked? Sure it can. How do you do it? Multiply it. I'm going to multiply this out and see what you get. What's x times x? X squared. X times 4a? 4ax. Minus 3 times x? Minus 3x. Minus 3 times 4a? Minus 12a. All right, I want to go through this. I want to check it, see if it's true. Did I get the first term? Yes. Did I get the second term? Yes, but it's in a different position. That's no problem. Did I get the third term? Yes, but it's in a different position. Did I get the last term? Yes. I want to claim it's the first and last guy that are easy to get. They really are. Really are. It's the middle guys that have got trouble. They really are. Okay, let's go to the next page. And next page is going to be that last step over here. And this is generally the part where students really have a tough time with it. They go on to say, if there's a quadratic factor of this form over here. Now, if it's this form over here, all I can say is that if it's in this form here, it's quadratic, a can't be 0. All right. So I gotta be honest with you, when I'm looking at this and someone says, well, if there's a quadratic factor, what do they really want you to do? They want you to use what's called trial and error to find the factors. I got to be honest with you, for a lot of students, they don't like trying. I like trying, including things that are really difficult. I like to try those things, including I'm just hunting and pecking for something. I need to find something that's going to work. Here's the deal, though. You're going to be given really simple problems. Trial and error would not work on a really difficult problem. It just doesn't work. But in simple problems, it does. What I mean by that is this. You're going to be given a problem where the first and last term really don't provide much choice. Let's go through that. I know it's tough, though. The first term is x squared. There's only one way that that would work using trial and error. It's got to be x and x, because x times x squared. Now, someone says, well, I could think of something different that would do it. And I'm not denying it. You could, but we don't want to think difficult. We want to think easy. Here comes my problem, the 14. 14 as a product could be written down as 1 times 14, 2 times 7. Now, if someone says, oh, it's too much choice now, I don't know which one to choose. You got to choose something. Right? I tend to choose the small numbers down. Someone says, well, what's small there? I'd say 2 and 7. I'm not saying it's going to work, by the way. I hope you can agree that x times x squared and 2 times 7 is 14. But now I got to get minus 14. So I'm going to put some signs down. I'm not saying it's going to work. I'm saying I'm going to try it. What does this give me? X squared minus 7x plus 2x minus 14. Well, I get the first term, last term. Unfortunately, I don't get the middle term. So this was not correct. This is my first try. First try didn't work. So I need to try again. This didn't work. So what's his name? You say, oh, I'll go back to 1 and 14. I hope you start to realize we got really close. This was minus 5. We want plus 5. So what I'm going to do is change the signs now. Again, I'm not saying that works either. I'm saying it's my second try. I'm going to give it a try. What do you get? X squared plus 7x minus 2x minus 14. Does it work? Did you get x squared? Yes. Did you get minus 14? Yes. The tough thing, did I get the middle guy? And I did. This is the only possible answer. Now, when I say that, some students often say, well, what if I wrote down x plus 7 times x minus 2? It's considered to be the same answer. Multiplications are commutative. All right. Factorizations are unique. You're not going to find any other factorization of that particular problem. All right, we can go to examples. Hopefully, as we go to examples, it'll become more clear what's the expectations at this level of the game. Thank you.